Right, Numan, hello. I'm just going to check your homework while we wait for Harris. Seems reasonable. So where's Harris then? Right, Harris, well done. Okay, cool. So let's get started, shall we? What we're going to do is look at circles today. I mean, we started already looking at them in terms of equations. We're going to look at them more kind of in terms of what they are, what are the major definitions you need to know about a circle, what theorems. So really, a lot of the ideas behind circles. So let's start from the beginning. Here's a picture of a circle. Well, here's a picture of a circle, which you can't see yet, so I'll move the camera. So there goes a circle. What's the outside edge called in maths language? What's the outside edge of a circle called in maths language? And you need to take notes as we go along, so I'm going to be using these words throughout. So what's the outside edge of a circle called? Type it in the chat box for me. Still waiting on an answer for that. So what's the outside edge of a circle called? Type down what you know, what you think it is. And if you don't know, type that in as well. It's circumference, quite right. The outside edge of a circle is called its circumference. Excellent. What is the line that goes from edge to edge through its center? So there's circumference for you if you didn't know how it was spelled. So circumference. What's the line that goes from edge to edge, but also go through the center? Diameter, brilliant. And just from the center to the edge? Just from the center to the edge, what's that called? Move the camera just a teensy bit so it's a little bit clearer to see. Radius, very good. Good start, good start. Now I'm going to teach you a few other ones. So if you may or may not know. I don't know, we're going to find out. So let's wipe this one off. So you guys need to have this copied down. That's your kind of sort of basic ideas. We're going to be using them, don't worry. Those are important ideas. Let's get this camera right. There we go. So I'll give you a few seconds to copy that down if you haven't already copied them. So you've got a few seconds to do that. Right, let's move on. So there's a few more definitions. We're not going to use them much today. Today we're mainly going to concentrate on working out the area and circumference of a circle and parts of a circle. But for next lesson, which is next week, there's a few others you need to know. So a line that goes from edge to edge of the circle goes through the circumference twice, but doesn't go through the center has a name. What is it called? What's that called? So a line that goes from edge to edge but doesn't go through the center, what is that called? Please say if you don't know. It's not an arc. That's not an arc. From here to there is not an arc. Chord, absolutely, it's a chord. Now the difference between an arc and a chord, so let me just dry this off a little bit. The difference between an arc and a chord is a straight line that goes from circumference to circumference. So it touches circumference in two places, does not go through the center. The arc does the same thing, but is the circumference between those 2 points. So this is the chord, and that is an arc. And thanks for reminding me that I need to tell you what an arc is. Okay? So that's a chord, and that's an arc. Chord. That's a chord, and that's an arc. Take notes for me. And then there's one more line we're going to worry about. What about a line that touches the circumference at 1 point only? So it only touches the circumference at 1 point. What is that called? A line that touches the circumference at only 1 point. It's a tangent. That's right. It is a tangent. That's brilliant. So that's a tangent. All right. Again, copy these down as notes. There's a couple more definitions I need to get you through, and then we're going to do area and circumference of a circle and area and circumference of parts of a circle, which is a bit harder. All right. So copy that down for me as quick as you can. Okay. If you have a circle and it's cut by 2 radiuses, it looks like this. So there's a radius there, there's a radius there, there's the center of your circle. I know it doesn't look like a center, but there we go. It looks like that, okay? What are the 2 names? What's the name of the small bit and what's the name of the big bit? What's the name of the small bit and what's the name of the big bit? So you've got two radiuses here. What's the area of this? What's the name of this area that's made from the two radiuses? What's the area? What's the name of this area made by the two radiuses? And the answer is not radius, clearly. It doesn't make any sense to call an area a radius. A radius is just a length. Yeah, a radius is just a length. So if you don't know, say so. Let me know. Yep, they're called sectors, but what's the specific name? They're both sectors, that's right. You're not wrong there, they're both sectors. That's correct, they're both sectors. But what's their specific names? They've got specific names. You're not sure? This is called the major sector because it's the big one. And this is the minor sector. Right? So this is the major and the minor. So the major sector and the minor sector. All right? So the big one's called the major sector and the small one's called the minor sector. All right? So major sector, minor sector. Take a note of that for me. All right? So the big sector, and sectors can only be made from two radiuses. All right? That's important because we're going to see something different in just a moment. Okay, so let's move on. There's another way you can cut a circle, which is using, sorry, I'm really getting tired of this now. Using a sector rather than a segment. Sorry, a segment rather than a sector, okay? So if you did a chord on a circle, let me just get this pen, probably works a bit better. A chord will cut something into a minor segment. So these are both segments, and a major segment. Okay. Again, take notes of that. So when it's cut by a chord instead of two radiuses, we call them segments rather than sectors. We're not doing much with segments today. We'll mainly be dealing with circles and sectors. That's what we'll be looking at. Okay? So write that down for me. So if you cut a circle with a chord, you get a minor segment and a major segment depending on the size of it. All right? That shouldn't take you more than a minute or so to copy. Okay, so I guess you've copied that out now. Okay, cool. So there's two major formulas you're going to learn, or going to hopefully have learned before and just recapping. And it's to find the circumference, which you remember is the perimeter, and the area. And I want to know, do you know these guys already? So can you pop in the chat box if you know how to work out the circumference or the area or both of a circle? So type that in the chat box for me. Right, so brilliant. Okay, so circumference is 2 times pi times radius. Let's get that so it's clear. And it seems like you know this already, so that's brilliant. So we can go on to the harder stuff quite quickly. We'll just do a few examples of this only. Pi times radius, right? So if you didn't know that, pop that in the chat. Yeah, so pop that in the chat for me. Not pop that in the chat, so take notes of that. We're going to do a couple of circles. It seems like circles is a strong point for you guys. So what we're going to do is move on to the hard stuff in circles when it's not a whole circle, when it's a sector of a circle. Okay? So we'll move on to that quickly. All right? So for now, just copy the formulas. Then I'm going to give you 3 questions to try. Work out the area and circumference of all 3. Okay? Once you've proven you can do that, then we can move on to more challenging things. All right? Just need to make sure that we've got it. All right? Okay, so I'm going to give you about another 30 seconds more to copy. Right, let's try some questions. Beautiful, thank you. Right, let's do some questions. I'm going to give you 3 circles to do, and I want the perimeter and area of all of them. So it should be nice and simple. So that's a 10, that's a 4, and that's a 3. Okay, so area and perimeter of all 3, please. I'll be back in just a moment. Just going to go and pick up my laundry. So the circumference of the first one is 18.5. 2 pi r 6 times 3.14. Yeah, I believe that. Keep going. Looks good. So far, so good. Right, so we've got area for that first one. Yep, okay, that's fine. I believe that. Let me just check that in my head. 9, yep. So this one would go 8 times pi, yeah, fair enough. 16 times pi, yep, beautiful. So far, so good. Not bad at all. I will say I'm happy with that. Just does look half decent so far. Keep going. Keep going. Right, looking good. Looking good. Let's just start our last one. Now, it's 5. Okay, so what have we got there? 10. Yep. So you guys weren't fooled by the diameter. That's brilliant. Well done. Good shout. Good shout. So what we're going to do is we're going to take it up to the next level, right? Because you already know this. Like, this is good that we've got it for revision, but you've not learned anything today. What happens if it's not a whole circle? What happens if it's a bit of circle? All right. So imagine you had here's your circle, and I put a line here, and I put a line there, and I'm going to call that, say, 40 degrees, okay? And my radius is 3, and I want to work out we don't call it a circumference, we call it arc length and the area. That's what we're going to work on. Now, can you copy the question out? So we'll do it together, okay? So it's the arc length and the area is what we're going to be looking at now. What's wrong with this stupid camera? It really does get on my nerves. Oh, there we go. So we're going to work out the arc length and the area. Now, the arc length, if you want to know what it is that thing. It's the line that goes from here to there. It's not the whole perimeter. We'll talk about the perimeter in a minute. Arc length is from here to there. And the area is just the area of the minor sector here in this case. It doesn't have to be the minor sector, but seeing as the 40 refers to the minor sector is what it is. Okay, hope that makes sense to you. That's what we're going to be looking at in the next minute or so. Take a minute, just copy that out for me, and then we're going to do that question together. All right, I'm going to do this question with you. Let's do it. So what we're going to do is we're going to do it together. I'm going to do arc length first, right? And it's basically, this is the formula. It's your angle, which I'm going to use the Greek letter theta for. May as well get used to it now. Over 360 times by the area. So it's times by the formula for the circumference. It's 2 times pi times r. All right. Now, you can also have a simplified version of the formula, which just goes theta over 180 times pi times r. You can choose whichever one of those two formulas is the one you're most comfortable with. I'm really getting frustrated with this camera. Just bear with me a second. I still want to take a swing at it in a minute. Okay, what the hell is the problem with it? Stop teaching. So I've literally, this is the only time of the week I use the camera. I want to start using an online, or at least a computer-based whiteboard. When I'm going to be able to do that, I don't know. Just bear with me a second. Guys, just wait a second, yeah? Let me just get this camera out for I'm going to really lose my mind. What's your problem? Right, also the fact it's a thick pen is not helping either. Right, so those are the two formulas for arc length, right? So we theta over, so 40 over 180 times pi times radius. I haven't got my calculator, where is it? I'll check that in a second. Oh, here it is. Shut up. You're not right. So here I'm just going to check that you got that right. It's 40 over 180. Gives you that. Times by pi. Times by radius, which is 3. 2/3 pi, 2.09, 2.1. Yeah, brilliant. Okay. So clearly Numan has got the idea on this. Can you copy down whichever the formula you like better? This one's easy to remember because it's just angle over 360 times your normal circumference formula. This one's slightly easier to do on a calculator. All right. So this is like, if you can memorize it, remember this. If you can't, if you know you're going to forget it, remember that. Because that's just the same formula. We just theta over 360 to stuck on the front of it as your circumference. All right. So that's your arc length. All right. Copy that down. As soon as you're done, can you put it in the chat for me? And then we'll move on to the next thing. Right. Let's go back. So, I presume you've copied it out at this point. I hope so, anyways. The area is the same formula. Theta over 360, this time times pi r squared. So pi times radius times radius. Okay? So it's the same thing. Theta over 360 just slapped on the front of your formula that you were learning before. All right? So I hope that makes sense to you, that when you're doing a sector, all you've got to do is do the angle, divide it by 360, and then multiply by your existing formulas. Right? there isn't a simplified version of this with degrees anyways. So all you've got to remember is just the one formula there. What I'm going to do now, I'm going to ask you to work out this one, work out the area and pop it in the chat for me. Once you've done that, I'm going to give you a more challenging question. Okay, so it's theta over 360 times pi times r is the area formula. It's the area formula. So this is the area. All right, that's the area formula there. All right, copy that down for me and then do the question. Work out the area of that minor sector. So, okay, so let's have a look at this one. So the area here is pi, you claim. Okay. 1/4, sorry, your 40s, that's going to be 1/9. Yep, it is pi. It's literally just pi. You're absolutely right. So, Numan, you've answered all the questions so far. It's been really good. So the next one, I want Harris to type in the answers first, okay? So let's see how well he does. This one's going to be a bit of a harder question. I'm going to give you a second to copy that down. The answer is pi, and it's going to be a second because you should have copied down the question before. There's no reason to wait any further. Right, let's roll. So here we are. I'm going to give you an example. Here is a slice of a circle, a sector. I want you to work out 3 things for me. So here we've got 60 degrees this time, and the radius is 10. I want you to find out the arc length. I want you to find out the area. And then I want you to find out something else. I want you to find out the perimeter. Let's see if you can do that. That's going to be a little bit of an extra challenge for you. So arc length, area, perimeter. Pop them in the chat box. Right. Not sure how to find. Okay, so we literally did it a minute ago. Yeah, and you hopefully wrote the formula down, right? It was you wrote two formulas down for the arc length. You pick whichever one you want. It's theta over 360 times 2 times pi times r, or you can have theta over 180. I don't care which; they both do the same thing. Times pi times r, because all you're doing is literally just timesing the 2 into the divide by 360. Those are your formulas for arc length. You wrote them down. Why is there a problem here? I mean, you can't say you're not sure if you took good notes. If you didn't take good notes, well, that's probably why you didn't understand it, right? But literally, there is a formula. Follow the formula, all right? So angle is 60. Put 60 into there and press equals, all right? That's why notes are super important. So if you're just sitting there and you're not taking notes, yeah, you're going to get bad. I've told you this a lot of times. But if you've taken proper notes, your answer is, oh, okay. So he's asking me to do arc length. Has he told me anything about it? Yes. Okay, fine. Let me do that then. That's literally how simple your life can be. So make sure you're taking top quality notes. No kind of like half-hearted notes. Top quality notes only. If you do garbage, then your results, the outcomes will be garbage. If you work hard, you'll do well. That's how it works, isn't it? Right, so we've got 10.5 as arc length. Yep, brilliant. Now, the last one you've got is perimeter. Have a think about that. Because you know enough math to answer that question. What is the perimeter logically going to be? 30.5 is perimeter, absolutely right. Because the two radiuses would be the other two values, wouldn't they? So we add 20 to 10.5, you get 30.5. Well done. That's better. That's better. All right, let's do a couple more of these. And then that's us done for today. That's the main thing you're learning today. Now, next lesson, I'm going to have a chat with your mum about how we're going to do it best. I'm going to ask her, first of all, when does she want me to come back to your house? I don't know if you guys are taking guests at this point. So it looks like everything's opening up. So I'll ask your mum probably And then if we are, then I'm going to bring some worksheets. I'm going to do something a bit different because circle theorems are awkward. Here are 3 sectors I want you to do. This is 20 and that's 8. That's 30 and that's 5. And that's just for a change of pace, 150. I know it's not, doesn't look like 150, but go with it. It's not 180, that'd be a straight line. 150, it's not drawn to scale, and that's 12, okay? So again, the 3 things I want from you, arc length, area, perimeter. So it's arc length, area, perimeter, okay? And while you're doing that, I'm just going to check the answers you gave for the previous question just to make sure you got them right, okay? So yep, looks good to me. So first claim, so we're just watching these ones. So arc length, area, and perimeter on those 3 sectors. They're not triangles, they're sectors. So arc length is 2.8, well, 20 degrees, 20. So 1/18 of 24. Might be. Let's have a go. So it's 20 over 360. Maybe 20 over 180 if we're going to do it that way. Times by pi. So it's 1 over 9 times pi. It's 1/9 times pi more. That's helpful, isn't it? Really? Oh yeah. Then you've got that. And then you times it by 8. Yeah. I'll do that one for the first one, arc length. Area 11.2. So again, it's 20 over 360, 10 over 180. So 1/18. Area is 11.2. Let's just work that one out. Answer is 11.2 for that. So that's pi r squared. So it's going to be pi times, what's that, 64 then? Not 67, 64. 11.17, 11.2. Brilliant. And then if that's 2.8, yep, yeah. So first one, Numan, yours is perfect. Harrison's going to check yours now. You've got area And it's, okay, what have you got there? So your arc length first, 2.60. So 30 over 360 times by 2 times by pi times by radius, 5/6 pi. Yep, looks good. Area is 6.54. We'll see about that. 30 over 360. Numan, don't put the answer for the third one. Let Harris do it. 30 over 360. Okay, that's fine. 1/12 times pi times radius times pi times radius. Don't put anything more, please. Radius times radius, so that's going to be 25. Area 6.54. Yes. You just need to finish on that one, Harris, for the area, the perimeter. Okay. Don't worry, I saw it. It's no harm done. But yes, Harris, can you finish off 2 and do 3 as well? Still have to work out the area. The area is not hard. All you got to do is just add the 2 radiuses to your arc length. Thirteen point 12.60. Yes. Really? Wouldn't it not just be 12.8? Why wouldn't it be 12.8? Add 10 to 2.8, you get 12.8, right? Oh, which Numan's question? No, I'm not. You've. Oh yeah, you're right. You're right. You know, you are right. Actually, tell the truth. Let's have a look. So your arc length was 10.47. Oh, yeah, I see what you're talking about. For 2, it's perimeter. How can that be? If the okay, what is the arc length for question 2? 2.60. Yeah, it makes sense. That makes sense. I've got it. I've got it. Makes sense, Harris. That's good. Right. So what I'm going to do is I'm going to put up your homework question. Okay, I'm going to put up some homework questions. Quickly take note of that third one, Harris. Make sure you get it done at some point. You did 2 though, so I'm sort of happy with that. I'll take that for now. I'm going to draw you some questions to do. Okay. In fact, what I'll do is you can finish this off now. Do this now. That last question. I'll write you questions and send your mum a picture of them. How's that? I'll get that sorted quickly. All right. So once you finish giving me the answer to this, as that's finished, I will send you your homework in a couple of minutes after that. Right. Okay, cool. Your perimeter spelling is hilarious, but other than that, let's have a look. Arc length of 3, 31.15. Okay, so what you're going to get is, what's that? What did I say that number was? 150? Let's have a go. So 150 over 180 times by 2 times pi. No, just pi, isn't it? So 150 times by pi times by 12. I got 31.4. Yep, that's right. Area 188.5. Okay, let's see. So 150 over 360 times by pi times by, well, that would be 144. Yep, 60 pi, 188.4. Yep, that looks good. And if that's true, then you add 24 to what you had the first time, and that would work. Yeah, brilliant. Okay, we're done here. I'll send your mum your homework. Bye.